Hello guys, welcome back. This is problem set 10 of the lecture series Signals and Systems. In this video, we'll be discussing some problems based on Z transform. So, let's get started. First question, let x of n equal to minus 1 whole power n u of n plus alpha power n u of minus n naught. Determine the constraint on the complex number alpha and the integer n naught, given that the ROC of x of z is 1 less than mod z less than 2. So we are given x of n as sum of two signals. So minus n power n u of n plus alpha power n u of minus n naught. And your ROC of this x of z is given as 1 less than mod z less than 2. So we know that a power n u of n will give us a z transform 1 by 1 minus a z inverse, and our ROC will be mod z greater than mod a. Similarly, if we have a power n minus a power n u of minus n minus 1, we'll have a z transform 1 by 1 minus a z inverse, and only your ROC is going to change. It is mod z less than mod a. So here if you see, we have only two signals. So minus 1 power n u of n will give us a z transform 1 by 1 minus a here is minus 1. So we'll have plus z inverse, and our ROC will be mod z greater than mod minus 1, which implies that our mod z is greater than 1. So this is the first part. So the second signal should give us something like mod z less than mod 2. So alpha power n u of minus n naught should give an ROC or a ROC mod z less than 2. So let us try to first generalize this. So if you have alpha power n u of minus n minus 1, we'll have a z transform 1 by 1 minus alpha z inverse, and our ROC will be mod z less than alpha, mod alpha. And again, if you want to bring this to this form, what we'll do, let's call it x of n. We need minus n naught. So we'll consider n plus n naught minus 1. So this will give alpha power n plus n naught minus 1 u of minus of n plus n naught minus 1 already. And this will have a z transform of, so you're shifted in time by n minus of 1 minus n naught. So your z transform will be z power minus of 1 minus n naught divided by 1 minus alpha z inverse. And your ROC will not change except for addition or deletion of 0 depending on your power of z. Addition or deletion of 0, and it depends on n naught, which means to say z power minus some positive number or z power negative. Then if you have 0, this will entirely blow up to infinity, correct? Again, we need to consider the denominator also, but you can get what I'm trying to say. Okay. So again, we want only alpha power n u of, this will be alpha power n into alpha power n naught minus 1 u of minus n naught plus 1 and minus 1 will cancel, having z transform z power n naught minus 1 by 1 minus alpha z inverse. So this one we can take it to the other side. So we'll have alpha power n u of minus n naught giving a z transform of alpha power minus of n naught minus 1 z power n naught minus 1 by 1 minus alpha z inverse. So your ROC will be either mod z less than mod alpha or 0 less than mod z less than mod alpha. So anyway, if you see, you only want, anyway mod z is greater than 1 from the first part, and you only want this thing. So your mod alpha should be equal to 2. So this is your constraint on alpha. And what about n naught? So does this 0 really matter? No, right? Because your lower bound is set by this first function, mod z greater than 1. So n naught can take any value. So these are your constraints on alpha and n naught. Okay, moving on. Second question. Consider the signal x of n equal to 1 by 3 power n cos pi by 4n for n less than or equal to 0 and 0 for n greater than 0. Determine the poles and ROC for x of z. So x of n, I can write it as 1 by 3 power n. Cos pi by 4 I can write as e power j pi by 4n plus e power minus j pi by 4n by 2 into u of minus n. So if I try to take the z transform of x of n, I'll have n equal to minus infinity to infinity x of n z power minus n. So this will give me n equal to minus infinity to 0, 1 by 3 e power j pi by 4 whole power n, and we have a factor of 1 by 2, right? Plus and z power minus n plus 1 by 2 summation n equal to minus infinity to 0, 1 by 3 e power minus j pi by 4 whole power n z power minus n. So if we replace n with minus n, what will we get? We'll get 1 by 2 summation n equal to 0 to infinity. This z also we can take inside, or we can leave it outside such that minus n will come, so that we can take it inside. So 1 by 3 e power j pi by 4 whole power minus n z power n plus half into summation n equal to 0 to infinity 1 by 3 e power minus j pi by 4 power minus n z power n. So this we can write it as summation n equal to 0 to infinity 1 by 3 e power j pi by 4 inverse into z whole power n plus 1 by 2 into summation n equal to 0 to infinity 1 by 3 e power minus j pi by 4 whole inverse z power n. So this is sum of GP. So it will be 1 by 1 minus r, because a is 1 anyway and your r is this term. So 1 minus r will be, so inverse of this is nothing but 3 e power minus j pi by 4 z plus 1 by 2 into 1 by 1 minus 3 e power j pi by 4 into z. So if you cross multiply, your poles will be same. So I'll take 1 by 2 out. So you will have 1 minus 3 e power j pi by 4z plus 1 minus 3 e power minus j pi by 4z divided by 1 minus 3 e power minus j pi by 4 z into 1 minus 3 e power j pi by 4 z. And for your ROC, what is the constraint? This one should be less than 1, right? So mod of 1 by 3 e power j pi by 4 inverse z should be less than 1, and this one also. Mod of 1 by 3 e power minus j pi by 4 inverse z should be less than 1. So this is nothing but your 3z less than 1, and here also 3z less than 1. So your z should be, mod z should be less than 1 by 3. So this will be your ROC. And poles, you can write the poles from here. So you have z equal to 1 by 3 e power j pi by 4 comma 1 by 3 e power minus j pi by 4. So since you have a real x of n, your poles are also complex conjugate. Okay. So let us move on to the next question. Question 3. Determine the number of zeros in the finite z plane and the number of zeros at infinity for x of z equal to z power minus 2 into 1 minus z inverse by 1 minus 1 by 4 Z inverse into 1 plus 1 by 4 Z inverse. So this is part A. And part B, they have asked let x of n be an absolutely summable signal with rational Z transform x of z. If x of z is known to have a pole at z equal to 1 by 2, could x of n be a finite duration signal, a left-sided signal, a right-sided signal, a two-sided signal? So first let us solve the first part, A. So we need to determine the number of zeros in the finite z plane and the number of zeros at infinity. So we are given x of z as z inverse square into 1 minus z inverse by 1 minus 1 by 4 z inverse into 1 plus 1 by 4 z inverse. So if z inverse form is confusing for you, you can convert into z. So if you see the order in the numerator, it is minus 2, minus 1, minus 3. And in the denominator, it is just minus 2. So I just multiply by z cube on both sides. I mean the numerator and denominator. Then what will you have? You will have z into 1 minus z inverse. So if you take it inside, you will have z minus 1 divided by, you keep 1z inside, 1z you multiply here. So you'll have z minus 1 by 4 and the other z you multiply here. So you'll have z plus 1 by 4. So now you have converted everything into the z form. So now you can easily spot the zeros, right? So 1 0 is at z equal to 1. So this is a finite zero. So where are the other zeros and how many zeros are there? So if you tend z to infinity, you can see that your x of z will go like 1 by z square, correct? This z and z by z cube you will have. So if you cancel, you will have 1 by z square. So at infinity, you have 2 zeros with order 2. So z equal to infinity, 2 zeros at infinity. So that is what they have asked. Number of zeros at infinity and number of zeros in the finite z plane. So 1 0 at finite z plane and 2 zeros at infinity. And coming to part B, let x of n be an absolutely summable signal with rational z transform x of z, and x of z is known to have a pole at z equal to 1 by 2. And it is also said x of n is absolutely summable. So what it means? It means your x of n is stable, correct? Or in other words, your x of z should contain the unit circle, which means your mod z equal to 1. So this you can also interpret as your discrete time Fourier transform exists, right? Both are same. So in the signal point of view, you can say your discrete time Fourier transform exists and hence should contain the unit circle. If x of z is a system transfer function, you can say that x of n is stable. The system represented by x of n is stable and it should again contain the unit circle. So both ways you can interpret and you will arrive at the same result. So if this is the case and it has one pole at z equal to 1 by 2, so at least x of z should contain ROC with at least mod z greater than half, right? So from this, what you can say, is it a finite duration signal? So for finite duration signal, what is the condition? Your ROC should be entire z plane. Of course, minus 0, infinity, except 0, infinity, or they can be included. So here is it the case? It is not the case, right? Because your mod z greater than half. So it is not a finite duration signal. Is it a left-sided signal? So for left-sided signal, what is the condition? So your ROC should be something like mod z less than something, right? Mod alpha. But here your mod z is greater than half. So this answer also is no. So I'll write in red. Is it a right-sided signal? So it may or may not be, right? May or may not be. Why? Because your mod z is greater than half. It can be constrained by mod z less than 2. The only thing is it should contain the unit circle. So otherwise, if it is constrained by between 1 by 2 and 2, then it is not a right-sided signal. It can be a two-sided signal. But they are asking, could x of n be a right-sided signal? Then the answer should be yes. It could. It should means it is like definite, 100% it should be. Could meaning they are asking whether it can be or cannot be, may or may not be. So your answer should be yes, it could be. So mod z is greater than half. Could it be a right-sided, two-sided signal? Again, the same reasoning. Yes, it could be. For example, 2 greater than mod z greater than half. This is one example where you have a two-sided signal case. Okay. So this is your question 3. So moving on to question 4. Find the inverse z transform of x of z equal to 1 by 1024 into 1024 minus z power minus 10 by 1 minus 1 by 2 z inverse for mod z greater than 0. Consider the following system functions for stable LTI system. Determine whether or not the corresponding system is causal. So we have two parts. So first let us start with the first one. So we have x of z given by 1024. That can be written as 2 power 10. Correct? So again 2 power 10 minus z power minus 10 by 1 minus 1 by 2 z inverse for mod z greater than 0. So mod z greater than 0 means your signal is right-sided. But also if you notice, it is covering the entire z plane with just by except for 0. So the signal can also be finite, right? Finite, and it should not include negative powers of z. Or I mean to say it includes negative power of z, only then z cannot be part of the ROC, right? So if you have z power minus 1, if you substitute z equal to 0, your x of z tends to infinity. So z will not be part of ROC. So z equal to 0 does not belong to ROC. So this is possible only if it is finite and it includes negative powers of z. So let us see what happens. So x of z, I can write it as, so 2 power 10, if I take it inside, I'll have 1 minus 1 by 2 power 10 z power minus 10 by 1 minus 1 by 2 z inverse. So this is nothing but 1 minus 1 by 2z whole power 10 divided by 1 minus 1 by 2z. So this is of the form 1 minus r power n divided by 1 minus r. Correct? This is nothing but summation r power n or r power k from k equal to 0 to 9. So your a will be 1 here, and you will have 1 minus r power n by 1 minus r. And there is no constraint on your r. If r is less than 1, you write it in this form. And if your r is greater than 1, you just multiply minus 1 in numerator and denominator, and you can write it in other form. So this is valid for all r. So then this is nothing but summation k equal to 0 to 9, 1 by 2 z power k. So this is like summation k equal to 0 to 9, 1 by 2 power k z power minus k. So this is your x of z. So now if you see, this looks like your x of n, right? And you have negative powers of z. That's why 0 is not part of your ROC. So your x of n is nothing but 1 by 2 power n for n equal to 0 to 9 and 0 otherwise. Okay. So this is your first part. And in your B part they have given this function and they are asking whether this is causal and they are given that it is stable. Okay, let us determine. So it is given that it is stable, so it should include the unit circle mod z equal to 1. So we can try to factorize the denominator. So we have z plus 1 by z plus 4 by 3 minus. So we can take out z power minus 3, z power minus 2 by 2. What will we left with? We'll have 1 plus 4 by 3 z inverse. So if you see this and this, there is only one factor of z difference. So we can again write this as z plus 4 by 3 into minus z power minus 3 by 2 into z plus 4 by 3. So this is nothing but z plus 1 by z plus 4 by 3 into 1 minus z power minus 3 by 2. So if you see, your one pole is z equal to minus 4 by 3 and other poles will be in the unit circle defined by mod 1 by 2 power 1 by 3, correct? So to include this unit circle, your mod z should be less than 4 by 3, right? To include unit circle. So the other pole is anyways less than 1. So other pole should be, the mod z should be greater than that pole. So if you see, for a causal signal, this shouldn't be the case, right? So not causal. It should be extending from the outermost pole to infinity. So this type of system is not causal. Okay. This is your B part. Moving on to the next question. Suppose we are given the following 5 facts about a particular LTI system S with impulse response h of n and z transform h of z. So the first one is h of n is real, h of n is right-sided, limit z tends to infinity, h of z equal to 1, and h of z has 2 zeros and h of z has one of its pole at a non-real location on the circle defined by mod z equal to 3 by 4. Answer the following 2 questions. Is S causal? Is S stable? So they are asking, given some set of facts about the system function and also the impulse response, and they are asking if the system is causal and stable. So let us go one by one. So causality. So from the first fact, what can you observe? Your h of n is real, which means your poles and zeros occur in complex conjugate pairs. Okay, so second signal says h of n is right-sided, which means your ROC will extend from outermost pole to infinity. But you still don't know if your h of n is equal to 0 for n less than 0. This is a question mark. Don't know yet. Because it only goes to infinity with or without infinity. So only if it does not contain infinity, then only you can say it is causal, right? So that your positive powers of z are not occurring in your z transform, and hence your h of n is equal to 0 for n less than 0. But this one we still don't know, without infinity or with infinity. So let us move on to the third one. So I think this gives us that information. Limit z tends to infinity, h of z equal to 1. So if you see, your h of infinity is less than infinity. So it is finite. So infinity is included in the ROC. So which implies that your h of z is, or the system is causal. System is causal. Why? Because if your infinity is included, it means there are no positive powers of z, which means that your h of n is equal to 0 for n less than 0. Hence the system is causal, and you can also see it is right-sided. So using these both facts, you can say that your system is causal. So then we should also consider two more properties, and we need to check for stability. So what is the fourth one? H of z has two zeros. So h of z has two zeros. So this along with your limit z tends to infinity, h of z equal to 1, what it implies? Your numerator order is 2, right? This implies this. And this plus this implies your denominator order should also be 2, correct? Then only you will get a finite number when you tend z to infinity, right? If either of your order is greater than the other, then it will either tend to 0 or infinity. So this should be the case. And finally what we have, so this means that you should have two poles. And the fifth point is h of z has one of its pole at a non-real location on the circle defined by mod z equal to 3 by 4 and non-real, which means the other pole also should be somewhere at 3 by 4, correct? So z will have poles at z equal to 3 by 4 e power j theta, comma 3 by 4 e power minus j theta. So which means your mod z should be greater than 3 by 4 because it is right-sided. And hence it includes mod z equal to 1, correct? So it is stable. So this system is both causal and stable. So this is our question number 5. So let us now try to solve some of the previous year gate questions. So first question, consider two discrete time signals x1 of n equal to 1, 1 and x2 of n equal to 1, 2 for 0, 1. So this is 0 and this is 1. The z transform of the convoluted sequence x of n equal to x1 of n convolved with x2 of n. So we need to find the z transform of this. So what will this be? You know that this is equal to x1 of z into x2 of z. Convolution in time domain gives product in the z domain or z transform. So x1 of n, if you take the z transform, what will you get? You will get 1 into z power minus 0 plus 1 into z power minus 1. Because your x of z is summation n equal to minus infinity to infinity x of n z power minus n. So your x1 of z is nothing but 1 plus z inverse. And similarly your x2 of n, if you take z transform, your x2 of z will be 1 plus 2 z inverse. So what is your x of z? 1 plus z inverse into 1 plus 2 z inverse. So if you multiply, you will get 1 plus z inverse plus 2 z inverse plus 2 z inverse square. So this is 1 plus 3 z inverse plus 2 z inverse square. So this is your answer, which is given by Option C. Okay, this is to the first question. I think GATE mostly they ask simple questions only based on the Z transform. Nothing complicated, but we should be accurate enough to give our answers. We should not make any silly mistakes. Okay. Question 2. Which one of the following pole zero plots corresponds to the transfer function of an LTI system characterized by the input-output difference equation given below? So they have given this y of n relation, summation k equal to 0 to 3 minus 1 power k x of n minus k. And what they are asking? They are asking the pole zero plot of the transfer function. So transfer function, we need to find h of z. So how do you do it? So we just first pass x of n equal to delta of n. Then your y of k n will be equal to your impulse function. So you first find the impulse function. What will you get? Summation k equal to 0 to 3 minus 1 whole power k delta of n minus k. So if you expand this, what will you get? You will get delta of n minus delta of n minus 1 plus delta of n minus 2 minus delta of n minus 3. So for this, what will be your h of z? It will be 1 minus z inverse plus z inverse square minus z inverse cube. So now we need to determine the poles and zeros of this. So let us try to factorize. 1 minus z inverse plus z inverse square into 1 minus z inverse. So this will be 1 minus z inverse into 1 plus z inverse square. So if we write it in terms of z, what will we get? We'll have z minus 1 into z square plus 1 by z cube. Just multiplying and dividing by z cube. And you multiply here z and here z square. You will get this. So you have a zeros at z equal to 1, comma, z square equal to minus 1. So z equal to plus minus root of minus 1, which is nothing but plus minus j, and the pole at, so we have third order pole. Where do we have? At z equal to 0. So this is what we will get. So how will our pole zero plot look like? We'll have 1 0 at 1, right? And 2 more zeros at plus minus j, and third order pole at 0. So which is this? This is option A, right? So this is also straightforward. You are finding the pole zero plot of your transfer function. Moving on, question number 3. Again, another pole zero plot questions. So let h of z be the z transform of a real valued discrete time signal, h of n, if p of z equal to h of z into h of 1 by z. So you need to note that it is real valued and your p of z is equal to h of z into h of 1 by z. As is 0 at z equal to 1 by 2 plus 1 by 2j. And p of z has a total of 4 zeros. Which one of the following represents all the zeros correctly? So before seeing this, let us try to write your h of z. H of n is real, right? Real value discrete time signal, h of n. So which means that your h of n is equal to h of h conjugate of n. This implies that your h of z is equal to h conjugate of z conjugate. So which means that if z is a 0, your z conjugate is also a 0 of this function. Okay. And you have p of z given by h of z into h of 1 by z. So if z is a 0, then your 1 by z is also a 0. Because if h of z is equal to 0 at z, your h of 1 by z will be equal to 0 at 1 by z. Correct? So from this condition, we know if z is a 0, 1 by z is also a 0. So we can get 4 zeros from a given z, correct? Z is given as 1 by 2 plus 1 by 2j, right? Okay. So z star, what it will give? It is 1 by 2 minus 1 by 2j. And 1 by z is nothing but, it will be 2 by 1 plus j. And 1 by z star also will be a 0, which is 2 by 1 minus j. So 2 by 1 plus j, how will you write? You multiply and divide by 1 minus j. So we'll get 2 into 1 minus j by 1 square plus 1 square, which is 2. So this is 1 minus j. And 1 by z star will be conjugate of this. So which is 1 plus j. So these are your 4 locations. 1 minus j, 1 plus j, 1 by 2 plus 1 by 2j, 1 by 2 minus 1 by 2j. So if we notice, so here the zeros are at 2 comma 2 and minus 2, 2 comma minus 2. So this is not the case. Here also it is 2 and 2. Here everywhere it is half. This is also not the case. So option D should be the correct answer. So as you can see, we have 1 by 2 plus 1 by 2j, 1 by 2 minus 1 by 2j, 1 plus j and 1 minus j. So option D is your right answer. So you should be careful that as soon as seeing z and 1 by z, you should not go writing 1 by 2 plus 1 by 2j to 2 plus 2j. So then you will make this mistake. You will choose this option instead of this one. But actually 1 by 1 plus 1 by 2 plus 1 by 2j is equivalent to 1 minus j. Right? That is what we got here. So these kind of places we need to be careful. Even though we know the concepts, we shouldn't miss out on these areas. Okay. Moving on. Question 4. Let x of n equal to minus 1 by n whole power n u of n minus of minus 1 by 3 whole power n u of minus n minus 1. The region of convergence ROC of the z transform of x of n is. So this is very straightforward. So minus 1 by n power n u of n will have a z transform 1 by 1 plus 1 by 9 z inverse. Even though this is not necessary, you straight away know for u of n, your mod z is greater than mod of minus 1 by 9, mod a, right? So your mod z is greater than 1 by 9. And for minus of minus 1 by 3 power n, u of minus n minus 1, your z transform is 1 by 1 plus 1 by 3 z inverse. And your mod z is less than mod of minus 1 by 3. Correct? Which means your mod z is less than 1 by 3. So together, what is your region of convergence? There is no pole zero cancellation here. So it is straight away mod z less than 1 by 3 less than 1 by 9. So if you write it the other way, 1 by 3 greater than mod c greater than 1 by 9, which is nothing but your option C. So all other options are different. Okay. So next, coming to question 5, let x of n equal to x of minus n. Okay, we have x of n equal to x of minus n. And let x of z be the z transform of x of n. If 0.5 plus j into 0.25 is 0 of x of z, which one of the following must also be a 0 of x of z? So this constraint implies that your x of z is equal to x of 1 by z. Why? You have this x of z equal to summation n equal to minus infinity to infinity x of n z power minus n. Similarly, if you have the z transform of x of minus n, you just change n to minus n, then you will get summation n equal to minus infinity to infinity x of n z power n. So this is similar to taking x of 1 by z, correct? If we take summation n equal to minus infinity to infinity x of n z inverse power n minus n. So this is same as x of z with replacing x z with z inverse, which is nothing but x of 1 by z. But from here you can always replace x of minus n with x of n. So which will give me x of n z power minus n. This is equal to x of z itself. So these both needs to be equal, right? So if your z is a 0, some z naught is a 0, 1 by z naught is also a 0. So z naught is equal to 0.5 plus j into 0.25. So your other 0 is nothing but 1 by z naught given by 1 by 0.5 plus j into 0.25. So here straight away they have given the answer. So option B is the right answer. So all these kind of easy questions only they ask, but you need to be quick enough to solve them. So for that you need to know these properties. And these properties are also not very difficult. Once you learn to derive them, once or twice if you derive them, you will get them. You'll be able to remember them. Even if you forget it in the exam hall, you can also quickly derive it because you already have the knowledge of deriving it previously. So you know how to quickly derive them. So this way you can save time in your examination. And time is a very critical element. So that is why a lot of practice and properly analyzing the theory part and questions and whatever you solve is important. So that's it for today, guys. I'll meet you in the next video. Until then, take care. Bye-bye.